Okay, we're working with this book, Modeling Techniques in Predictive Analytics, Business Problems and Solutions with R. It has some pretty good reviews. It's available in our library, and the author is faculty director of the Predictive Analytics program at Northwestern University, which is a new program, but one of the first programs around. And and I have some of it here, but I can't share it with you. I can't lend it to you, rather. But this is the first chapter. And we have the data set, though, for this book. So I asked you to go to Blackboard, which, if you go to Blackboard here, you should see data set here, and you can download that. Okay, so please download it. Unfortunately, it takes a bit of time to unzip it, because it has in one of the chapters, there's a lot of social media data, which seems to take a long time to unzip. Must be a lot of data. Okay, anyway, so let's look at the code for chapter 1. So this is chapter 1. So it looks like this. There's these different chapters here, and here's chapter 1, and you should have R open as well. And you can just right-click on this file, and you can open it in Notepad++. And it should look like that. So this is when the file extension is .r like this, the Notepad will treat it like this. In other words, it'll give these colors and so on. Okay, and so, by the way, you can change the language here. Like there are many different programming languages. You could call this something else, and it would change the coloring. But we want it. It's appropriate for R, so we want to keep it this way. Okay. So I guess let's see. So while you're downloading and extracting this file, because it can take about a minute after you download it, or maybe even 2 minutes after you download it to extract the file. So while you're doing that, I'll just quickly look at this text for a minute. Okay. So in chapter 1, a kind of introductory chapter, and this chapter is called what? Analytics and Data Science. And he says predictive analytics brings together management, information, technology, and modeling. It is for today's data-intensive world. Predictive analytics is data science, a multidisciplinary skill set essential for success in business, nonprofit organizations, and government. Whether forecasting sales or market share, finding a good retail site or investing opportunity, identifying customer segments and target markets, or assessing the potential of new products or risks associated with existing products, modeling methods and predictive analytics provide the key. Okay, let's just quickly see if they give us the table of contents for this. This never gives that, does it? Or maybe it's here. Oh, here it is. Okay. So the table of contents is chapter 1. Then we're going to do chapter 2 as well today, called Advertising and Promotion. This one is going to take a bit longer to do. It's called Preference and Choice. And then Market Basket Analysis and Economic Data Analysis. We might skip Operations Management and go to Text Analytics. And if we still have time, we'll do Sentiment Analysis. Okay? And this is all done in R, so that's why we've spent a good amount of time learning R. And we didn't learn everything that we need to know, but you should feel, like you know what R is about at least. Okay, and that you know how to look up different functions, and maybe you know how to understand the documentation that R provides, because it's kind of tricky, right? Okay, has everyone, can everyone get this first file open? Anybody not able to get it open? Let me just find Excel. I want to make this, okay? So we're going to use a sort of well-known data set called the Anscombe Quartet. So let's read this into R. Now just to remember, there are various ways to create a data frame, and one would be just to read the data from a file, but that's not what we're doing here. We have a number of vectors here, x1, x2, x3, x4, y1, y2, y3, y4. So we are going to load it in like that. So we're going to create a data frame with this many columns, right? So let's take a look at, let's enter that. Okay, can everyone find this? This is chapter 1. Let me just show you once more. So it's in chapter 1, then you right click on this, you open it with Notepad, and you should see this. Anybody not find it? Should I explain? Because we're going to be referring to this over and over and over and over and over again. Okay, so if you don't have it, let me know now. I can help you. Okay? Okay, so let's put this into R. Okay, so now we have Anscombe. And the first thing we can do is let's find the mean for each row of this. Or actually, so how can we, okay, tell me, how can we find the mean for x1? How would we do that? So one way to do that would be right? Does that work? Mean Anscombe $1. Okay? How about, give me another way to find the mean. Or another way to reference x1, in other words.
Square bracket.
All right, okay. So he said this. Right? That should work, right?
No.
No?
You need the comma.
What's that?
You need the comma before.
Oh, right. Thank you. Thank you. I want the comma before. Right, thank you. Okay, this should work, right? This should give you the first column and then the mean of that. How about another way to do this? Is there another way? Yeah, how about, that's not the one I'm thinking of. No, I don't think quotation marks. Well, oh, right. How about that? Quotation marks. Yeah, that works. So what would that be? X1. Good. No. What's wrong with that? What about a single quote? Does that work? Why doesn't that work? No? Why not? Okay, I know, I'm not sure. Okay, how about another way? How about width? Using width. Will that work? Let's see. Yeah. Okay. So remember that we can use with, right? What does with do for us? Once you say with Anscom, then you don't have to type Anscom all the time, as long as you're within the with brackets. Okay, everyone see this? Okay, how about what's the mean of x2? Can you get that? 9. Okay, how about the mean of x3? Okay, and how about the mean of x4? Okay, how about the standard deviation of x1? Okay. How about the standard deviation of x2? What's that? Yeah, they all look the same, right? x1, x2, x3 probably the same thing, x4 probably the same thing, right? You understand? Now go back and look at this data again. Are they the same? No, they're not the same. Oh,
X4
they are the
is
same.
for the rest of the same.
Oh, what happened? Sorry. These are the same. That's weird. Is that right? So, it's like a mistake. Okay, try it with y1, y2, y3, y4. What do you get? Oh, I'm sorry, I was doing the wrong thing. So yeah, try it with y1, y2, y3, y4. So what do you find out? So let's try the standard, the mean of y, different y's. Okay. Okay. How about the standard deviation for the different y's? Okay. All right, you getting the picture? So it looks like for the y's, I didn't mean to look at the x's. It looks like for the y's, the means and the standard deviations are all the same, even though the numbers are different, right? Okay, let's do one more analysis of this. Let's look at this. Now, what does this part inside here do? Just that part, what does that do? So we talked about that in our last video, right? In our last class, we talked about regression, right? And this is the way that R does regression. Okay, so it's going to make a linear model of it's looking at the relationship between y1 and x1. Okay, so that's just the inside, and then we can. And what's this width do, by the way? That just allows us not to have to type all the Anscom over and over again, right? Okay, so and what does this summary do? Actually, let's try one more summary. Try summary of Anscom, just by itself. What does that give me? Okay, you see that? Summary of outcome, what does it do? Tells me the minimum, first quartile, medium, mean, and maximum, and so on, right? Tells me, it summarizes each of these variables. So from that, we could get all the means for y1, y2, y3, y4, right? You can see the mean of y1 is 7.5, mean of y2 is 7.5, and so on, right? Everyone see that? Okay, so that's the summary function. Everyone get it? Try it yourself. Does it work? Okay? All right, so now what he's going to do, though, now, by the way, now he's doing summary of the linear models. So he's going to make these linear models, these regressions, and do the summary. So let's try just the first one, see what we get. Okay, so it's pretty confusing, right? You guys are not statisticians, and you don't know too much about this, although I wish you did. I wish you had more statistics. I wish we had more here. But anyway, so we don't really know how to read all of this stuff, but at least these two things I can explain to you, and you actually might already know. What are these two things here? Remember we did this in Excel, and the intercept and this were what? This was the slope for the line, and this was the y-intercept. Okay, do you remember this from last time? We did this in regression, right? Last time in Excel. Okay, so we see that what we're doing, by the way, is of course, we're looking at the relationship between the y1 variable and the x1 variable. We're asking basically, can we predict y1 from x1? And we find the slope, we find the line that fits this data best, and it has an intercept of 3 and a slope of 0.5. The other stuff, we don't really know what it means. The only other thing that I might explain here is, here it is. The multiple r squared. These numbers here, like multiple r squared, adjusted r squared, what they tell you is how good a prediction you're doing. Okay, if this was 1 instead of 0.66, that would mean you'd have perfect prediction, perfect predictability. That would mean that the data, if you look at it in a graph, fell exactly on a straight line. Okay, as opposed to what we might have, which is data looking like this, and then the straight line there. So the data doesn't fall exactly on the straight line. But if the data fell exactly on a straight line, it would be perfect predictability, and that would be 1 for these numbers. But anyway, it's not. It's 0.66, but we're not going to be concerned with those numbers right now anyway. But the numbers we are concerned with are the line. So the line has intercept of 3 and slope of 0.5. Okay, now do the same thing for all of these relationships here. So let's just do it again, but use all of them, and see all the results. Okay, and what kind of differences do you get? Scroll through and check the results. What about the lines for each of these? What did you find out? Tell me what you get. They're all the same, right? Right? It's 3 and 0.5 here, and the next one was 3 and 0.5 basically here, and so on, right? 3 and 0.5 basically here. Does everyone follow what we've done? Okay, so from all of our analytical techniques, what do I mean by analytical techniques? I mean, we looked at the mean and the standard deviation and even the line that relates the data. These seem to be the same. Okay? But are they really the same? Are these really the same data sets? Like X1, Y1, or x2, y2, or x3, y3, are they all the same or not? Well, if we do the analytics, they appear to be the same, right? But, so the whole point of this chapter is that we should do visualization. Okay, we should try visualization as well as the analytical techniques, because as we know, visualization can provide interesting information. So how about doing the visualization? So how does he do it? So what does this do, by the way? This is going to make a PDF file, right? We're going to make a PDF file. He's going to call it figure more Anscombe 2 PDF, and then he's going to make it. He's going to do all of this, and anything else we can see here? Title, step 2. Okay, let's try and run this, and see what happens when we do this. So let's run this. This is going to make a PDF file in your folder, right? And you know, we have different, so this, remember the PCH, if you went through the homework, you saw that this sets the kind of the plotting character. So or you can use like a diamond or a triangle or a dot or whatever. And the color and the stuff, you know, makes it look pretty. Okay? But anyway, let's just run this and see what we get. Remember, we're trying to understand these data sets and see if they're the same. According to all our analytics, they are the same. Okay, now let's check and see what we got in our working directory. Where's our working directory, by the way? Here. Okay, are they really the same? Are these data sets really the same? No, they're very, very different. Okay? They all, if you draw a straight line through them, they're all going to have the same straight line, actually. Looks weird, but that's true. Okay? If you take the mean of the y values, they're all going to be the same. If you even look at the standard deviation of the y values, they're all going to be the same. Okay? So the point is that just doing certain limited analytics can really lead you astray, right? So you can't just believe a limited set of analytics. Even, you know, just looking at a picture may not solve the problem all either. But the point is that you can be led astray. Okay, so it's kind of word of caution. Okay, does everyone understand the idea? Any questions about this? So yeah, I mean, maybe you don't understand all the code here for plotting, but you could go and look for what's this argument do in the plot. Does anybody know what this does? X lim and Y lim? Did we do that? I forget. I think we didn't do it. But what is that? So if you didn't have that, the plots wouldn't start at 0, probably. They'd start, the graph, like here, it starts at 0, and 0, it would probably start around 4 instead. Okay, so you can adjust it with that parameter. Okay, any questions about this? Okay, so now that's chapter 1. So let's go to chapter 2, which is called Advertising and Promotion. Any questions before we go on? So you can open up chapter 2, the data set for chapter 2. And also take a copy of this dodgers.csv file and put it in your working directory. So put the dodgers.csv file in your working directory. Here. Okay? In fact, let's look at that data set first. Let's look at the Dodgers data set. Did we look at this last week? I forget. Anyway, we did, right? Yeah. Okay. Anyway, just quickly review. So just open it up. And you can see that there are how many variables in this data set? 1. Okay, how many variables? 12, right? What are they called? Month, day, attendance. What does attendance mean? What is this, Dodgers? Well, okay. Let me go through this next. Is everybody following me? Okay, so this is modeling techniques and predictive analytics, advertising and promotion using R. Okay, so I think I showed you this last week, right? These are bobbleheads for the Dodgers baseball team rather. And actually here, if I can get this to run. How do I turn on the volume here? Let's see, can I do it? No sound. Why not? I don't know why. But anyway, you can see what these things look like. This is a promotional tool that, I don't know why it doesn't work. Can't hear it. Anyway, you can see what this thing is, right? So they're passing it out, and why are they doing that? Just because they're generous? Just because they're kind? Probably not, because they're fairly expensive to make. So it's a promotion, right? So they're trying to get more people to come to the game, or something, or maybe branding or something like that. But they're trying to do it. And this is Adrian Gonzalez, who I guess is a big star in this, in baseball. Okay? So that is the bobblehead. Okay? There he is. Okay, so promotions using bobbleheads for baseball games. And the question is it financially worthwhile? What is the cost of doing it? And what's the return? And how much does offering bobbleheads increase sales? And what effect does it have on the bottom line? Okay, so a management question might be, will bobblehead promotions increase attendance? And will the increased revenues associated with tickets and concessions cover the fixed and variable costs of putting on the promotion? Okay? So that's what we're wondering about. What's the difference between fixed and variable costs? So I guess the fixed costs are like, I don't know, you have to ship them to the stadium and so on. And then the variable costs are like, each bobblehead costs a certain amount. So if you have 10 bobbleheads, it costs one amount. If you have 10,000, it costs a different amount. Okay? And you need to cover both of those, right? Okay, so this is data-driven marketing, right? So we want to open up this file, dodgers.csv, and we're going to look at this code as well. I'm not sure why he has the app history, but I mean the history file as well, but you know what the history gives you, right? If you load the history file, then if you use the arrow key, you can scroll through that history file. Okay, so this is the data, and we can see the months are like April, May, and so on. It's probably not the winter months, and the days, and the attendance, and the day of the week, and the opponents. So some of the opponents are called Pirates, others are called Padres, Braves, Nationals, Giants, Rockies, and so on. The temperature, this is in Fahrenheit. So this is like a fairly warm, a nice day. And this is a little bit cold, not really cold. This is a nice day, okay? And then the skies can be clear or cloudy. Okay, so that Why do we include the skies? Because that's weather, right? And that's going to what? Affect attendance, right? So it would be a reasonable variable to include in our analysis, right? We're trying to, what is our analysis going to be about? Whether bobbleheads increase sales and how much they increase sales. Can we even say how much they increase sales? And then day versus night, that might have an effect on attendance, right? Whether it's a day game or a night game, right? Some games are during the day, some games are at night. Okay, now this one is called cap, and that means, did they give a hat as a promotion? So they also, not only do they have bobblehead promotions, they also have hats or caps, okay? And they also have shirt promotions, okay? And they also have fireworks. So some, special nights, I guess, they have fireworks and maybe people come more because of the fireworks. And then, of course, we have bobbleheads. Okay? So this is the data that they chose to include in order to make the predictions. Okay? Now, of course, you could search for other data as well and include that as well. If you think there are other factors that may play a role in this, you might look for other data. Like even, who knows, maybe economic data, macroeconomic data. It seems a little bit not so likely, but who knows, right? Could be macroeconomic data. What else? I don't know. There could be lots of other things that could affect the attendance. Okay? So now you might say, well, wait, we're just trying to figure out whether bobbleheads affects, but you want to include all the others to sort of account for the other variables so that your bobblehead figure, the result that you get for bobblehead is more significant or more substantial because you've included all these other variables as well. So you've accounted for all these other variables, then the number that you come up with for bobbleheads will be more accurate. Okay, but anyway, let's keep going. So this is Dodger Stadium in Los Angeles. Looks like a nice stadium, I guess. And the capacity for Dodger Stadium is 56,000 people. That's the maximum number. And if we go back and check your data set, take a look at when was it filled to capacity. So go back and check in your data set and see when was it filled to capacity. When was there 56,000 attendees? Go back to your your CSV file, open in Excel. So when was it? The first game, and there was one other. Who were they playing on the other one? Who? The first game they had filled to capacity, and what about the other time? Who were they playing? Who? Giants. What? Is that the New York Giants?
That sounds right.
I think it's the New York Giants, or it might be, I think it's the New York Giants. But anyway, so maybe it's kind of competitive, right, between New York and Los Angeles. I'm not sure. Or otherwise, we're not sure. Why was it filled to capacity on that day? How about were there fireworks on that day?
They gave away bobbleheads.
They gave away bobbleheads. Did that do it? Maybe. Were there fireworks on that day? No fireworks. Okay. All right. So next is, we noticed that there were only two cap promotions. So if you check the data, it turns out there were only 2 cap promotions and only 3 shirt promotions. But really, that's not enough data to determine, whether caps and shirts are what effect they have. If you just have 2 cases, it's really not effective. It's really not. You can't really figure out the effect. Okay, and also if you just have 3, it's not enough. Okay. On the other hand, there were 13 fireworks, so we could do the similar analysis for fireworks, but we're going to do, specifically, we're going to observe, we're going to be talking about bobbleheads. Okay, so 11 bobblehead heads in night games, and 6 were on Tuesday night. Okay? So we're just noting those facts. Okay, now, run the code to reproduce this graph. So we're doing some exploratory graphics, and so try and run this code right now. So go to the, we want to, I don't have chapter 2 open yet. So go to open chapter 2 data. Okay, now, first of all, we're going to use 2 packages here. One is called CAR, which doesn't mean automobile, it's just a short name for something, car, and the other one is called lattice. And lattice is for making fancy graphs. Okay, there's a nice package for making fancy graphs called lattice. So we want to install both of these. So how do you install these? So you could do it this way. I think this works. Okay. Yeah. So then, but you could also, so then you have to select, get a mirror. Well, yeah. So you could do it that way, install the package. And it downloads it and installs it. Or you could have done it this way, packages and install packages here. Okay, you could do that, install packages. And the other one was lattice, so I'll do that one. Lattice. It's up here under packages, and you click that and you see install packages. So lattice here. And okay? Can everybody get them installed? Okay, now there's a difference between installing them and being able to use them. What's the difference between installing them and being able to use them? What do you think is the difference between installing them and being able to use them? Does anybody have any question about how to do this? Install dot packages, and you put it in quotes, or the other one was lattice, so you could also do that for lattice, or you can do it from here. Install packages, that's an easy way. Okay, just choose the, okay? So what's it now? We installed them. What's the difference between installing a package and using it? What do I mean?
After we install it, it's still in our library, so we cannot use it. So
maybe that's it. I was going to say, you might be right. He said, after you install it, it means you downloaded it into the computer, but it's not in the library. I was going to say, I think it's not in memory, but maybe he's right. Maybe it's just not in the library, or maybe it's just not in memory. I'm not sure actually which it is. Okay, but you have to bring it into either, I don't know if we have to bring it into the library or into memory, but we have to do that. So you can use the library function, which is here, here. So you can bring them into, I don't know if it's the library or the memory, but you can do that. Let me just do something here. Just turn this on. So I want to bring those into the library, so we do that. And there's another command you could use instead of library. You could use require instead of library. It would do the same thing as far as I know. So it gives me a warning, but warning is different than an error. Okay, so warning means something about, we'll ignore the warning. Okay? Okay, now what do they do in the next line? Line number 7 here, what are they doing?
In the Excel file.
They're loading the data into a variable called what? Dodgers. Okay? Everyone agree with that? Everyone agree with that? Okay, so you should have Dodgers in your working directory, so that Dodgers.csv, so you should be able to load it there. Okay? All right, now what do they do? Now, what's this line do? By the way, the print, I don't think you really need that. You could just have str.dodgers. Does the same thing as print. So, what is this doing? What line is this doing? I'm sorry, what is this line doing? str.dodgers is going to do what? Check the structure of what? Of this Dodgers variable that we just created. By the way, when you use read.csv, what does it get stored as? A data frame, right? So we'll see that when we run this. So let's run this and see the structure of what we just did. Okay, so what does it say? What kind of object is this? It's a data frame. And what are these things listed? What is it showing here? These are the variables, or the columns of the data frame. And what does this say here? 81 observations. What does that mean? 81 rows of data. So if you check your Excel file, there should be 81 rows. And how many variables are there? 12. Okay, now the first variable is month. And what type of structure is it? It's a factor, right? Okay, so when you do this read.csv, it automatically turns it into a factor. It turns any character string into a factor. Okay, if you don't want that to happen, you have to specify somehow in here when you do this that you didn't want it to, all the characters to be read as factors. Okay, you have to tell it. Otherwise, it's going to make a factor out of every character string. Okay, so it's a factor. Month is because the months are names, right? So that's a factor. But day, it didn't do that because days were numbers, so integers. And attendance is also an integer, but day of the week is a factor, opponent is a factor, temperature is an integer, and all the other ones are factors. Okay, everyone get it? Now look at bobblehead. How many levels are there for bobblehead? What does level mean?
How far back in the data
Sorry?
frame? How far back it goes in the data frame?
No. What does level mean? Level, no. That's not what it means. Level means how many different values does that particular variable can it take? So bobblehead, what can it take? What values could it be? Only yes and no, right? So there's 2 levels. Okay, levels means the values that the variable can take. Okay, how about day-night? That's also only 2 levels, right? So, what are they? Of course, they're just day and night, right? Okay, and how about month? How many levels are there? Well, you might say there are 12 levels, right? But there aren't 12 levels occurring in our data set. How many levels are occurring in our data set? Just 7. Okay? Now you might get confused and say, okay, so these are the levels, so what are these numbers doing here? And like these are the levels, what are these numbers doing here? Right? You can get confused about that. Anybody know the answer to that?
It's the order of the variables.
The order?
Yes, it's like 1 for no and 2 for yes.
Yes, that's right, yeah. That's right. Remember, I think we said somewhere along the line that R stores factors as numbers so that it can manipulate them more quickly. Okay, R stores factors as numbers so that it can manipulate them more quickly. So what it's saying, for example, up here, is the first row of data was 1. The second row was 1. The third row was 1. What do you think 1 stands for? 1 stands for April. Okay, why are these all 1? Because the beginning games, the first few rows of our data set were all from April, right? So it's just showing the first few here. So they were all from April. What about here? What does this mean? Like the fireworks one. Means the first, second, and third rows were 1, which means they didn't have fireworks, but the second one was 2, which means that they did have fireworks. Okay? You understand? So it's just giving you a sample, or the first few rows of the data here, but it's stored as numbers. But the actual values were no and yes, but it's stored as numbers, okay? Just trying to make this printout a little bit more clear, right? So we understand what they're talking about here. Okay? So, and this is the integers, the actual temperatures, right? Are here. Okay, any questions about this? So that's the structure of our data frame. Oh, and these variables, like bobblehead, fireworks, shirt, cap, day, night, they only have 2 levels, so we could call them binary variables. Binary means 2 levels, or 2, right? So sometimes you'll call them binary. Or sometimes you'll also call them Boolean, but I wouldn't call them Boolean, but you could call them binary. Okay, any questions? All right, so we've taken a look at the data set. Now, let's go back to here. Okay, now, here is something we haven't seen before, and that is if-else. Okay, now, I had a choice when I decided how to teach this class, and that is, should I keep going on with just the R, because we haven't covered everything in R that I wanted to cover, or should I start teaching, the application, and even in spite of the fact that we don't know all the functions that we need to know in order to do the applications. Okay, so I decided that you guys might be getting impatient, and so I decided to start to do some analysis like this, even though we don't know all of the functions that we need to know. Okay, so one of them is we don't know if-else. So look that up right now and see if you can figure out the structure or what if-else is doing. So look it up by going to R and exploring it a little bit yourself right now. So see if you can figure out. But before you do that, let me just mention one thing, and that is here, before we use if-else, what are we using here? With. So what are we doing? With what? With the data equals Dodgers. So we only have to refer to what here? We only have to refer to the variable names here. We don't have to say Dodgers, blah, 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 right? Each time, okay? All right, so see if you can figure out this if-else. Okay. First of all, just to understand if-else itself. So see what it does. I'm going to even stop this video for a minute while you explore that. Okay. If I can figure out how to access that. How do I close this here? No. So what are they in mine? What are my arguments? The first one is what? X is greater than 5. The second one is what? Super happy, right? Right? And the third one is what? Oh, I spelled it wrong. Another if-else statement, right? Else. Right? Another if, so the third argument is another if-else statement, right? So what is that going to do? So if x is greater than 5, what's it going to do? It's going to do this, right? Super happy, right? But if x is not greater than 5, then what's it going to do? It's going to run the second if-else statement, right? So what will it do? What will that second statement do? It'll test, is x greater than 3? And if it's yes, then what? It'll say happy, but if it's not yes, then it'll say sad. And I need two sets of parentheses here, right? This one applies to this one, and this one applies to this one. Right? Do you understand? Okay? Now I could keep doing this, right? I could, have 3 if-else, or 4 or 5 or 100, right? Does everyone understand? Okay? So, we have what he wrote is here. So look at his code now. And it's all about what variable? It's all about day of the week, right? It's testing day of the week. Now what does double equal sign do? What if we didn't have a double equal sign there? What does that do? If you don't have a double equal sign, what does that do?
Assign the value.
That assigns the value Monday to this variable. I don't want to do that. That's not what we're doing. We're doing a test, a logical test. So you need double equal signs because the single equal sign will screw everything up. Okay? So you need double equal sign. So what's the first test? Just like our first test was what? I'm sorry. My first test was what? Is x greater than 5, right? Okay, what's the first test here? Is day of the week what? Equal to Monday. Now what is day of the week? Well, if we go back here, for example, we can see that day of the week is a factor with 7 levels. Could be Friday, Monday, and so on, right? It's the days of the week, right? It's a string variable, which it codes as a factor. Okay? So, what are we checking? Whether our day of the week is Monday. If day of the week is Monday, then assign that 1. Okay? If day of the week is Tuesday, but if it's not, then check if day of the week is Tuesday, and if it is, assign that 2. And if it's not, then check if day of the week is Wednesday, and if it is, assign that 3, and so on. Okay, so why is he doing this? I'm not really even sure, but that's what he's doing. Okay, he's creating a new variable here. I forgot to mention that. So what's this first line? What's this first line? Ordered day of the week. Is there such a variable in our data set? No, look at it here. Is there an ordered day of the week here? No, it's not there. He's creating a new column. He's creating a new variable, okay? So what is this new variable going to have in it? So it's going to be equal to either 1 or 2 or 3 or 4 or 5 or 6 or 7 when we're done. Okay, now why is he doing this? I'm not even quite sure, actually.
You can so that when it displays on the graph, the days of the week are in order.
Yeah, I think you're right. Okay, so he said because when we do it on the graph, right, you're right, that's right. The days of the week are going to be, this is going to be in order. I think. Okay, so anyway, he's doing that. And so you can do that too. Let's do that right now. So add this line in, add this whole thing in. And now you have a new variable, which is, if it's Monday, it's 1, if it's Tuesday, it's 2, if it's Wednesday, it's 3, and so on. In fact, you can even, if you wanted to, let's write this to a new CSV file and check it by looking at the Oh, there's another way to do this, by the way. How do you do that? I think you do this. What is it? I forget. There's another function that allows us to, data editor. Okay, there. Okay, so you can do that. So let me show you that again. You go to View, no, you go to where was that? Edit, here. You go to Edit and Data Editor, and then it says type the name of the data frame you want to look at. Okay, and we have a new, where is it? Up there. We don't have ordered day of the week, but I thought we just added it.
Maybe further across.
Sorry?
Maybe further across.
No, I didn't see it. But, should be there. Let's try that again. Fixed Dodgers. Should be there. Didn't we just add it?
Yeah, you scroll across at the bottom.
Sorry?
You need to scroll across on the bottom.
Oh, really? Okay. Or we can do it this way. So now you can see that ordered day of the week is there as a column. Okay, does everyone get this? You can use the head function to see the first 6 rows of the data frame. And I can see over here that we now have another variable called ordered day of the week. All right, let's keep going. Okay, now, what's he going to do on line 19? What's he doing on line 19? What's one thing that he's doing on line 19? The most basic thing he's doing on line 19. He's taking ordered day of the week, which we just created, and he's recoding it somehow because it's still ordered day of the week, right? What's he doing here? He's making it into a factor, okay? So if you make it into a factor, some of the functions that we can use work, that if we don't make it into a factor, they don't work. Okay, so he's going to turn it into a factor, and then he's going to add some extra arguments in there as well. In this factor function, he's going to specify the levels, and he's going to give labels. So now we're going to have labels for this ordered day of the week variable, and the labels are going to be, obviously these labels. Okay, so you can run that as well. So try running that. Make a factor out of it. And see if we can get it to work. And finally now he's ready to graph it. Okay, all of that to just make a simple graph, a relatively simple graph. So you'd say, God, this is a horrible language, right? You do all this just to make a graph, a simple graph. But anyway, that's the way it works. So let's do it here. So exploratory data analysis with standard graphics, attendance by day of the week. Okay? Now, what's this part do? That allows us not to have to refer to the data frame name all the time, right? Same as we've seen many times already. So what's he doing beyond that? He's plotting. Okay? He's plotting this variable. Now I think we've only seen plotting when we have two variables, like we plot x comma y. Right? Isn't that true? When we did the plot function, we were doing x and y, and so we got these points, right? Like a scatter diagram, or something like that. But here, we're only plotting one variable. Okay? And it's a factor. Now, it's a little bit technical, but when you run the plot function, if what you're putting in is one type of structure, it'll do one thing. If it's a different type of structure, it'll do something else. So if it's a vector, it'll do one thing. If it's a factor, it'll do something else. And when we say do something else, it actually calls a different function to do it. So if we put in a factor here, which is what we're doing, it actually calls a function called plot.factor. So if you want to know what it's going to do, you have to look up this function to find out what it's going to do. So you can look up plot, and then in the documentation it'll say something about factors, and you click on that, and then it'll bring you to this plot.factor, and then you can read what it's going to do. Okay? But that's the way it works. That's called, what's that called in programming? It's called, I forget right now, polymorphism or something like that. I forget what it is. There's a programming terminology for that. But anyway, it's like one function is actually many functions. So maybe it's called polymorphism. Because this one function, depending on what you put in it, it actually calls a different form of the function to do the work. And it has like a technical name in programming. I think it's called polymorphism. I'm not sure. Okay, anyway, so it's going to call a special function because this is a factor. And as I said, we're used to putting in the arguments for a plot are usually x and y, like two variables, but here we're only putting in one. And then this has another, anyway, let's just run it. Let's do this and see what we get. Okay? So what's the variable that we're plotting here? Day of the week, right? And the y, oh, and the other argument here, actually, yeah, I was a little bit wrong. It does take two arguments, but the first one is a factor. So it is taking a second argument here. And the second argument is a 10, but it's actually a 10 divided by 1,000 because they just want to scale it. Okay, so you can do that right in the argument. Okay, so he's scaling it by a factor of 1,000, so he doesn't want to have such big numbers here. So 45 means what? 45,000, right? And 40 means 40,000, okay? So we did that, and the X label is day of the week, and the Y label is attendance in thousands, and the color is violet, and I forget what this does right now. Okay, you can look up this argument to see what it does. Okay? So what can we see? Okay, now we're trying to do some analysis here, and we spent like the last 20 minutes just looking at the R code, but we really want to look at the analysis. So what does this tell us, if anything? Is it useful to have done this at all? So these are called, in statistics, these are called box plots. And if you've taken statistics, you should have seen these. And this black line in each one of them is what? Does anybody know? It's not the mean, it's the median. So in other words, look, here's Tuesday, right? Does every Tuesday have the same attendance? No, right? It's not the same every Tuesday, right? So there's a spread, right? So sometimes there's maybe attendance is only 40, and sometimes it's 55, right? So this is trying to, first of all, this color, this block here is telling me about the variation in that data. So here, the variation is less than it was on Tuesdays. Okay, on Fridays, the variation was less than it was on Tuesday. So apparently Tuesday, there's a lot of variation in how many people come to the game. So it's less easy to predict what's going to happen on Tuesday, right? Whereas on Monday, there's less variation. Okay, do you understand what these are? This is what this is called. These are called box plots. And what when you do plot on a factor, where is it? Plot on a factor, it automatically prints a box plot. Okay? So now, how about the top? Does anybody know this? What is this number and this number? What are these called? Or what are they referred to? Like this number here is about what? About 48, right? Or let's take this one. This number is about what? 37, and this number is about what? 33. Okay, so what are these numbers? What are these numbers? 37 and 33. What? Yeah, but why does the box start and end at these two numbers? What is the significance of these numbers?
Minimum, maximum.
Not quite. The actual minimums and maximums are more like this number and this number. Okay, so it's not quite the minimum and the maximum. Okay, if I tell you that in our class, you got in your final exam that you got the 95th percentile score, would you be happy or not happy? Is that very high or very low? 95th percentile score. So we give you an exam, like all APU students, and your score is like you take a math test with like all 6,000 students take it, and your score is the 95th percentile score. Is that a good score or a very bad score? No. It's a very good score. 95th percentile means what? You are better than 95% of the people that took the test. Okay, 5 percentile score means, yeah, it's hard to say. You might think that you're in the top 5%, but that's not what it means. The 5 percentile score means you're in the lower. You only did better than 5% of, okay? So what these numbers are, this was what? 37 and this was 33. This is the 75th percentile and the 25th percentile. Okay, so this, what does that mean? 37 means what? So 75% of the games had less than 37,000 people, right? And what's this, how do we read this number? 25% of the games had less than 33,000 people, okay? So that's called the inner quartile spread. It's the inner quartile means this 25th percentile is called the first quartile, the median is called the second quartile, and the 75th percentile is called the third quartile. So between the third and the first means between the 75th and 25th is called, that distance is called the inner quartile spread. Okay? So it's a way of measuring the spread, right? So here, look at this one. On Thursday, the inner quartile spread is really big, right? That means the data is very varied. Okay, is this clear? Sort of? Okay? So anyway, all right, so what can we tell from this, from analyzing this curve, this data, this graph? Well, we can tell that, like we said, Monday there's not much variation, but on Tuesday and Thursday there's a lot of variation, so it's very hard to predict what the attendance is going to be on Tuesday and Thursday, right? Because there's a lot of variation. Or at least we need to have other factors to know. And how about this? This is the median. That's the 5th 50th percentile score, or the 50th percentile attendance. That means that 50% of the games were more than this number, and 50% of the games were less than this number. Okay? Is this clear? This is just statistics. Okay? So, all right, so we got this picture, finally. Okay? All right, let's keep going. All right, let's go back to, oh, okay, all right, let's go back to this. Okay. So we have this, you just made this yourself. So I said, what if anything went wrong? I mean, did you have any trouble getting this graph to work? Okay, we want to install the car and lattice, we did that. You can use library or require, like library car, lattice, library lattice, and put dodgers.csv into the right folder, we did that. And then we read this into, so this creates a data frame, and this does what? This shows us the structure of our data frame. And here, I just pointed out that this comes from the documentation. You can override the default. So when remember we use the factor function, and you can override the default levels by specifying a levels option. So we did that. For example, here would assign the levels as 1 is poor, 2 is improved, and 3 is excellent. So we needed to do that. So you can go back and check that. So here's the if-else, right? And we did this. Okay. And now if we look at, so we create a factor, we said that. We create a factor for ordered day of the week. And so if we print it out, we see what here? We see number, these are the days of the week, right? So this is a factor. The levels are 1 through 7, and we get these numbers. So what this levels 1 through 7 does is it says that Monday will be the first day of the week, will be assigned 1, and Tuesday will be assigned 2, and so on. Okay, so we have this. And then we also added in labels. So now when we do Dodgers order day of the week, what do we see? We don't see the numbers anymore. We see this, the labels, because we added in the labels here. Okay? So you can check this out a little bit more later. Okay. So if, okay, let's go on. Okay, here's what we did. We printed this out. We created this graph, rather, by running this code. So what if we want to know what's happening? We ask what are the axes. So the axes are day of the week and attendance. And we ask what can we see in this graph. Okay, here it is. Okay, so we can get everything. Okay, here's some more code. Okay, so how about this one? Your boss asks you, in the past, in terms of days of the week, how many times did we run the promotion and how many times did we not run it? So we want to see, in terms of days of the week, like Monday, on Mondays, how many times did we run our promotion? On Tuesday, how many times did we run our promotion? And how many times did we not run our promotion? On Wednesday, how many times did we run our promotion and how many times did we not run our promotion? Okay, your boss wants to know this. Do you understand what your boss wants to know? So why would he want to know this kind of information? Why would he want to know, like, on Mondays, how many times did we run the promotion?
To compare with the previous graph.
To compare with the previous graph. Ah, that's right. So if we knew that, then what could we say about this? Right, that's right, right? So we might say, oh, look, the median is really high here, right? It's like the average, kind of like the mean is really high here. So what might we ask about Tuesdays? How many times did we run the promotion on Tuesdays, and how many times did we not run it? Right? So that's right. So that's the kind of question that your boss is, I mean, that's the question your boss is asking now. How can you get the answer in R?
I don't know the exact code, but something like if
There's a really simple,
really simple,
there's a
then
one function answer. But what were you going to say, by the way?
I was just gonna say, like somehow using the other graph, just then add in the
For graphically do it. Yeah, that would be another way, right? To look at, to add in. But I think we need this function first to count it. So we want to count how many yes and no's are there for bobblehead, right? We're going to have to, even if we do it your way, we're still going to need something to count it up. And that's what we want to get here. Counting. Anybody remember how to do this? Not so, I'm not sure you would remember, but we did do something like this already. So let's look at it. So here it is. So of course you can ignore the width, right? We already know what that does. So what's the function? The table function. Okay? So try this code and see what you get. So it should be in our, here. Yeah. So run this code and see what the output is. Okay, just copy the code from the R file. So what code did we run? What was the main function we were using here? Table, right? And how many arguments did we put in it? How many arguments are there?
2.
2, right? In fact, let's just try it just with the first argument. Let's just run that again with just the first argument. So let's get rid of the second argument. Just to simplify things. So let's just try that. Table on bobblehead. What's that going to do? Okay, what is bobblehead? Oh, that's not going to be interesting, is it? Oh, there it is, yeah.
Frequency.
Okay, do you see what I just did? I just tried, okay, first of all, we did this one, table, bobblehead, and order day of the week. But now I said, let's make it simpler. Let's just do table, bobblehead. So what do we get when we do table, bobblehead? It's a counting function. Table is a counting function. So what does it count? Bobblehead can take on how many values? 2. What it does is just count how many there are in each category. Okay, we have how many rows of data? 81 rows of data, right? Some of them are what? Yes for bobblehead, and some of them are what? No for bobblehead. What does the table do? Just counts up how many are in each category, or how many are in each level. Okay? Try it for a different variable. Try it for a different variable. Table for some other variable. How about cap? There's no cap. What did I do wrong?
you do dodges.
I didn't use width, right? Yeah, but I may as well just try that. Or, like you said, I could just use dodgers. Okay? You understand what the table is doing in this case? How about, let's do day of the week. Or maybe How many categories are there for ordered day of the week? 7. So it gives me for each one. Okay, is this clear? It's counting. Now how about if we use 2 variables, what's it going to do? So then it's going to take all the different combinations of both of those variables. Right? So if we do like they asked us to do, that one, if we do that one, how many different combinations are there of these two variables? So bobblehead can be what? Yes or no. And day of the week can be what? Monday, Tuesday, Wednesday, Thursday, 7 days, right? So how many combinations are there? 14, right? 2 by 7, right? There's 14 different possibilities, right? And it's going to count how many are occur for each of those possibilities, right? So that's what it does. So let's run it. Okay? So now, what did the boss ask you? One thing we wanted to know, which was Tuesday, right? Tuesday had a high mean, right? And so we wanted to know what? Were there a lot of bobbleheads that time? And I'd say yes, compared to the other ones, it was high, right? So we can see that here, right? Okay? So, that's all we have time for today. So, that is, so we'll continue with chapter 2. We're going to finish chapter 2 next time. And when is next time, by the way? Not next, do we have class next week? No. So the week after that. So we also have, I'll have to post the information, but we're going to have an R test. Okay? Going to be about 20 minutes. Okay, I'll give you details so that you don't have to study everything. I'll try and make it focused, but we will have an R test at the beginning of, and it'll be at the beginning, so be here on time. And by on time, I mean 10 minutes early so you can get your computer running. Okay? So we'll have an art test on Blackboard, and that'll be in 2 weeks. And then we'll continue with this next time, and maybe we'll get into chapter 3. Okay? That's all. Yeah?
Is it midterm exam?
Sorry?
Is it midterm exam?
Yeah, midterm exam.